Hi, good morning. This is Dr. Vicky. I'm going to make a little bit of clarification here on the difference between data and the visualization of the data. Are you ready? Let's go. The agenda. We're going to talk about what exactly is data. We hear it all the time, but what is it? We're going to use a periodic table of elements to visualize what is data. Data consists of elements and properties. Visualization, we're going to talk about graphical properties of the visualization, graphical elements of the visualization, and what is a spatial substrate for the visualization. Let's talk about data first. Data is all around us. But what exactly is it? Data is a value assigned to a thing. Take, for example, you. You too have data attached to you. You have a name. Most people have given and family names, maybe married names, maybe nicknames, maybe names we don't really want to share with everyone. Data. Everyone has a date of birth. Again, that's data. Weight, data. Height is data. Nationality is data. These are values used to describe you. You can probably think of several others, such as hair color, eye color, favorite food, favorite flavor of ice cream, chocolate's mine. All of these things are data. They're values assigned to a thing. You. Visualization. What is a visualization? Visualization refers to a graphical representation of information in data. By using visual elements like charts, graphs, timelines, and maps, data visualization is an accessible way to see and understand trends, outliers, and patterns in data. Let's use us again. Let's talk about trends in data. If we track height, what our height is on the same day of the year every year for 20 years, and then draw a trend line, we're going to see what is the trend. Is our weight increasing, decreasing, staying the same? That's the trend. Outlier. Let's say we're tracking our height and it goes up from when we're tracking it from age 0 to 18 an inch a year. And then all of a sudden on one specific year it goes up 6 inches. That is an outlier. It lies outside, well outside of the trend line. And patterns in data. That all refers to the visualization. Now, let's look at the periodic table of elements. In chemistry, probably not my favorite subject, but it's a perfect visualization of data. Let's look at the periodic table in form of the data that it represents. Again, it's a visualization of data. Data is what drives the visualization. It's the information behind the scenes that populates the visualization. Each square on this periodic table represents data. Let's look at the one I have circled in orange, periodic element Ne, which is neon. The element, the periodic element in chemistry, neon, is data. Every one of the elements on this table is data. The data is arranged by atomic number. If you look closely, you'll see 10 on the neon block. 10 is the atomic number, the atomic weight. That, again, is property of the data, but it is data. Data equals elements plus properties. The element of neon and its property, 10 of atomic weight, that is your data. The data, which are the elements, neon, and atomic number 10, dictates how this whole entire visualization is laid out. So again, it's driven by the data itself. Let's look at the visualization. Look at the visualization that the data helped us to create. The graphical properties. Now we're talking about how this visualization is laid out. The graphical properties of a visualization are the characteristics: size, color, shape, orientation, position. On this particular visualization, the purple column of elements circled in white represent graphical properties of the data. It's representing all of the elements that are alkaline earth metals characterized by shiny and silver white. But the graphical property is purple column, purple blocks, row and column of each element, which is the data, results in groups of elements with similar characteristics. So that is the graphical property of the visualization. Graphical elements of the visualization refers to points, lines, surface, and volume. The graphical elements in this particular visualization are points. Now, when you read in your textbook exactly what points are, in this particular instance, it refers to the squares, the blocks on this visualization. Each block of an element. This element, right here, circled in blue, is considered a point. The spatial substrate of the visualization refers to space and type. The spatial substrate in this particular visualization, the space is 2D, two-dimensional. It's flat. The visualization is flat. It doesn't move. It doesn't pop out at you. It is flat. And the type is quantitative. How is it quantitative? Because it's organized and laid out by numbers, measures. Summarize for you. Data, when we're talking about data, is values. It's name, age, weight, date of birth, height. When we're talking about visualizations, we're talking about timelines, bar chart, pie chart, heat map, scatter plot. So when we're talking about data and visualization, we use a visualization to make the story behind the data clear to an audience. I hope this clears things up. If you need anything from me, don't hesitate to let me know.